Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2020, 10B, Problem 14, and it deals with geometry. I hope you guys enjoyed this video and let's get started. The problem states, as shown in the figure below, 6 semicircles lie in the interior of a regular hexagon with side length 2 so that the diameters of the semicircle coincide with the sides of the hexagon. What is the area of the shaded region inside the hexagon but outside of all of the semicircles? So essentially, we're trying to find the shaded region, and I'm going to draw out some points here. So I'm going to let A be this vertex right here, and then I'm going to let B be the midpoint of the diameter or of the side length of the hexagon. And then I'm going to let C be this point where the two semicircles touch each other. And then I'm going to connect these 3 points. This is going to be C. Connect these 3 points because we see that this is actually an equilateral triangle. And why I say that is because, well, we know that this is the whole diameter is side length 2. So that means that if B is the midpoint, that means that AB has a side length of 1. And then BC is also 1 because that is the radius of the circle. Well, we also know that angle BAC, this angle right here, this is 60 degrees because we know that the full angle, for example, this whole angle of a hexagon, that has an angle of 120. And so BAC is just half of it, so that's 60. Well, if two side lengths is both 1, if they are both 1, and then we have one angle which is 60, then that means that this is an equilateral triangle. So that means that this angle is also 60 degrees. Well, the area of a hexagon can be found with the formula 3 times the square root of 3 times s squared over 2, where s is the side length of the hexagon. So that means that in this case, our area would be 3 times the square root of 3 times 4 over 2. And this can be reduced to 2 times the square root of 6 times the square root of 3. And then we have equilateral triangles here. So the area of an equilateral triangle is square root of 3 over 4 times s squared, where s is the side length of the equilateral triangle. And it's really important that you know all of these crucial formulas, especially these basic ones, because it really saves you a lot of time. And so s is the side length of the triangle. Well, our triangle has a side length of 1, so this is just square root of 3 over 4. And then we can also find out the area of a circle, because here we have 6 semicircles. So technically the area of the full circle can be found using the formula pi r squared. So in this case, we have pi, and then we have to multiply by 1/6 because we can actually divide this into 3 circles within the semicircles. So that means that we technically divided the whole circle into 6 equal sectors. And now we can look at this. So we see that in each 6 of the hexagon, so basically in each of the semicircles, there are 2 equilateral triangles that are colored white. So A, B, C, and then we also have this triangle right here. And then there is 1/6 of a circle with a radius 1, so basically this sector right here. And that is also colored white. So this has an area of pi over 6, and then the 2 equilateral triangles each have an area of square root of 3 over 4. And then, so this is the same with each of the semicircles within the hexagon. And the reason why I drew these triangles is because if we were to just calculate the area of the semicircle, that'll be really straightforward. But you see that these sectors overlap right here. This would overlap, and we would count that twice. So by drawing these triangles, I'm only counting them once, like these little parts right here. So the total area that is colored white in each of the 6 hexagons would be 2 times the square root of 3 over 4 plus pi over 6, and that would give us square root of 3 over 2 plus pi over 6. Well, we have 6 of these because there are 6 hexagons, so we multiply this by 6. So this would be the area of the parts that are colored white. And then it's asking us for the shaded area. So we have the area of the full hexagon, which is 6 times the square root of 3. So it's just 6 times the square root of 3 minus 3 times the square root of 3 plus pi. This would give us 3 times the square root of 3 minus pi. So the answer is D.